Hey guys, this is going to be a short introduction to some of the skills required for you to effectively investigate characteristics of the periodic table, the organization of the periodic table, and then ultimately being able to establish patterns on the periodic table. Now, the periodic table is not a random kind of positioning of elements. There are particular reasons why elements are in the position that they are. And so the process by which that was determined is by knowing a lot about the elements and then being able to group them by similar characteristics so that patterns are discernible so that the periodic table makes sense. And so you can see that there's different numbers of elements in different columns, there's different numbers in different rows, there's this kind of island of elements down here at the bottom. There's a reason why hydrogen is over here and helium is over here, and there's this big gap in between, even though they're in the same row. So the goal for this particular set of activities is to establish some of those overarching patterns in regard to figuring out why things are where they are. And one of the most foundational skills is being able to draw these things called Bohr models. And Bohr was a pretty famous scientist that came up with a way to draw the configuration of electrons that allow for certain patterns to arise. And so this will allow us to not only determine general size of particular molecules or certain elements in terms of their atomic size, but also some other characteristics in regard to valence electrons, which are something that are important that I'll talk about in this video, and then also how that means that they will bond with other elements and a lot of other things. So let's just kind of jump into it. So a Bohr model is a way to represent where electrons are in their shells, and that is something that I want to explain. So we know that electrons are found around the nucleus, and they're kind of like those are the ones that are kind of like circling the nucleus. We know that they're negatively charged. We know that they're really tiny because they don't carry much weight. And the other thing that we know is they're really hard to locate. And so sometimes they're described not existing in a particular position, but existing in an electron cloud. And sometimes these clouds are classified by shells, and this is just a way of us kind of depicting something that really isn't depictable. So just a model or representation of something. So the Bohr model takes into account all parts of an atom. And so that's why it was so important for, in the first set of lessons, for you to be able to say, oh, I know how many protons, neutrons, and electrons there are, because that will be articulated within these models. So let's draw the Bohr model for hydrogen. It's always nice and easy to start at the beginning. So the first thing that you want to do is you want to kind of label your drawing, hydrogen, and then you want to draw the nucleus. And you may want to do these numbers things first. So the first thing you want to do is write the number of things that are in the nucleus. So we know from hydrogen that there's 1 proton and 0 neutrons. The next thing we want to do is draw the first shell, or the first level of organization for electrons, and that's a circle around the nucleus. Now, there are particular numbers of electrons that go on certain shells, and it's pretty easy, but the explanation for that is way beyond what we need to cover in this course. So the first shell can hold a maximum of 2 electrons. But since hydrogen only has 1, we can just draw 1 dot on that first shell, and we have drawn our Bohr model. Now I know that was anticlimactic. It does get more complicated. So let's draw another one. Something that would require 2 shells. Let's look down at lithium, the next one in that column. So we know that lithium has an atomic number of 3, so we know that it's got 3 protons. That'll tell us it has 3 neutrons, and its atomic weight is about 7, so we know that it has 4 neutrons. We can then draw our circle. So we know that lithium has 3 protons, so it has to have 3 electrons. However, this first shell can only hold 2. So we put 2. You try to space them out evenly. It's not I'm not really critical at this point. But you put 2 on the first shell, and then you put a second ring or a second shell here, and you can put the third one kind of anywhere on that. So this is an accurate representation because everything is depicted appropriately. 3 protons, 4 neutrons in the nucleus, and 3 electrons in the appropriate number of shells. Now the next question you might have is, what about, how many can the second one hold? It can hold 8. And that's the same rule for every shell after that. So the only thing you need to remember is the first shell can hold 2, the next shell can hold 8, and every shell after that can also hold 8. And that's important for bonding, and that's something we'll cover in a later lesson. So let's try sodium. Sodium has 11 protons, and it's got 23 minus 11, so 12 neutrons. We draw our first shell. Now we need 11 electrons. So we've got 1 and 2 on the first shell. That one's full. We draw our next circle. Now we can draw 8 on this one. 1, 2, 3, 4, 5, 6, 7, 8. And that's a total of 10. So we know we need one more shell, and that shell will have one of them. Now, this is an accurate representation. We can tell a couple things from this. We know the equal distribution of each of these, 11 protons, 12 neutrons in the nucleus. We then have 11 electrons surrounding the nucleus in the appropriate amount of shells. So questions I may be able to ask: how many shells of electrons does sodium have? And if that was the answer, you'd have 3. You'd have the first, second, and third shell, even though the third shell only has 1. So we have 3 shells. I could ask you, how many full shells does sodium have? In this case, it would only be 2, because only the first shell, which has a full set of 2, and the second shell, which has a full set of 8, would be full shells. And the last thing I would want to ask you are number of valence electrons. And valence means outer, or the outermost portion. So how many electrons are in the outer shell? In this point we only have 1. If I were to ask you these same questions up here, lithium has 2 electron shells, one of which is full, and just 1 valence electron. Hydrogen would have 1 shell, none of which are full, with 1 valence electron. Now, you might be wondering, how does this end up telling me anything about the organization of the periodic table? What we will be able to do is, after you complete Bohr models for a certain amount of elements, we will be able to put that on the table in their positions, and then you'll be able to start to think about, what sort of patterns do I see? But what it really comes down to is being able to construct these Bohr models so that you can know as much as possible about each of the elements, so that those patterns are just a little bit more recognizable.